Posted. Okay, so let's see where we're going.
Hey, good evening.
Good evening. Okay, I just heard from Angela. So I'm leaving work now, but with heavy rain, it may take close to an hour to get home. I will hop on the Zoom as soon as I'm able to. Okay, so that's Angela. And then we have DJ. And now I just need to see if I heard anything from Trish. So enough Trish, sorry, from Tristan. Yes, Trish, you're there. We've been chatting. Okay, so let me just look there. Give me 1 second. Okay, so I haven't heard anything from her. So why don't we... Okay, so I have, DJ, I have your reflection paper. Thank you, that was good.
Yeah, I just want to say I'm not the best writer, but I am a beast at math.
I thought your first paper was totally fine. So I would not, do not.
It's not my strong suit.
And what else did I want to say about that? Oh, and DJ, look at the posting for today, because I said post the article that you want to write about, or that you want to do your...
Yeah, I had a question about that.
Mm-hmm.
So I tried to type it in because did you want to, because you said post the title. So I tried to type the title in, but it said you can only upload documents. So did you want the article, the actual article I'm using, instead of just the title?
Yeah, go ahead and pop that up. Did you have that issue? Trish, I think you posted yours, right?
I just wrote, like, because I'm technologically very challenged. So I just made a paper and just like a Google Doc that said the title and then just posted that.
Okay, so yeah, that's
I was gonna do that too.
So you can do that also. And then I would say that by the time the presentation comes, probably attach your article. So if someone else wants to perhaps use that, if they thought that was a good one, that they would use either in their own class or maybe in future classes that they're taking, then they would have access to that. So I would say, as long as you have it down, so we know kind of what the different topics are, that's fine.
Okay, thank you. All right.
You're welcome. So
I'll do that right now.
I'm going to try to get your paper read tonight, DJ, because everyone else's I've gotten read. So I will try to do that. And I was telling Trish that the power didn't go, but the internet went at our house for a little bit. It came back on. So should that happen like mid-sentence, know that I will post this. Hopefully it will not happen, because everything seems fine now. I have no warnings about a bad connection. So I think I'm good. So why don't we go ahead and look at this? So we're winding down. I mean, it's amazing, but we are getting there. So this is chapter 8 is all about quadratics, which is also called parabolas. And they spend so much time in high school on that. They do it in at the end of algebra 1, they do it in algebra 2. They don't really do it much in geometry, although occasionally you'll have factoring problems, and even in a geometry class, and factoring is all about parabolas. And then when you get to calculus, that's how they start out, with analyzing parabolas in terms of a calculus method, looking at slopes and looking at rates of change and profit functions and all kinds of things. So calculus is where it really becomes super obvious to kids how you can use this stuff. I mean, the calculus classes I've taught like the ones that are either environmental calculus or they are business calculus. And at no point does anybody ever say, how would you ever use this? Because every single lesson, you're showing them exactly how you use it and why it's a very practical math. And it really takes you to that point to have all your maths alive. So you've got your algebra 1, your algebra 2, your geometry going, you've got your pre-calc going, and now you're going to make sense of it all. So, you know, sometimes when you talk to the kids and they say in algebra 1, when am I ever going to use this? Well, algebra is the language of math. So you will always use it going forward. And you know, you need it in everyday life, you know, even, you know, balancing your checkbook, figuring out your taxes, figuring out the cell phone rate, what's the best rate for car loans, what's your student loans going to be, all of that stuff is based on algebra. So there's a lot of your articles, you reflected on how important it is to make that connection with the kids. And it's important with the adults too, so that they can see it too, so they can explain it to the kids. So let me get into this. I'm just going to open up my iPad and switch over to the notes for today. So we're going to talk about standard form, and then we're going to talk about vertex form of a quadratic function. So remember, quadratic are those little parabolas. it's when the power is to the power of 2. And DJ, are you teaching Algebra 2? What are you teaching?
Yeah, I teach Algebra 2 honors. So actually, the flow of this class is the flow of my curriculum. So
Yeah.
it just kind of reinforces what I'm telling my students. Like we just got done with vertex form actually. But the way in which you teach it, I kind of pick up on language. Like you said, each form gives you a gift. I say that
Yes.
to my students, but I don't use the word gift. So like I like how you explain things because I kind of try to mimic it when I'm teaching it to mine. So yeah, we're on we just got done vertex form.
Okay, good. Yeah,
Mhm.
so I think I use the same language with lines because in calculus, it's all about tangent lines to curves, and every type of form you get gives you a certain insight. And so I
Right.
would call them gifts because, the kids will say, well, I know this one form. Well, that's awesome. But you know one approach, but there are other forms that give you more information, and you just
Right.
want to be aware of them and be flexible. Because a lot of this changing from one form to another really just totally emphasizes your algebra skills. That's what you do
Yeah.
all the time.
Yeah.
That's good. You feel free. You don't need to copyright me or anything. Just quote me anytime you want. Okay, let me see if I can share screen here. Okay, that's a good sign. So it went pretty quickly. Okay, so this is the, let's see if I can get that out of the way. Nope, I don't want to do that. So now we're starting to do strange things. I never should have said it worked so well. So let me go here. Okay, let me try this another way. Okay. Still doing weird things to me. Okay, that's better. Okay, so it's starting to do its thing. So something definitely went awry. That was last year's, and this is this year's. Okay, so this is where we are today. So that's the end of the notes. This is the beginning of the notes. So we're doing quadratics, and remember that a quadratic is just when you have x squared and the mathematics of motion. Okay, so we're all talking about quadratics are great functions to do, like when you throw a ball in the air, what happens to it? It's all about motion, and it's very, very helpful math. So that's why we spend a lot of time studying quadratics. Okay, so the standard form versus the vertex form. So here is your standard form right here. Now, you can get the vertex from the standard form, but you've got to do some math. Okay, so first off, you've got to recognize that these A's, B's, and C's are really important, and the sign comes along with them. So you can get the vertex. So this is what they call the H and the K. And what is that? Say you're doing the parent function, that would be the point 0, 0. Those would be your coordinates. So you can get it from this form, but you're kind of getting it indirectly. So there's a way to take this form and manipulate it so you can just see the vertex form. So what do you get from this form? Well, this form they talked about in the last section, right away, you get the y-intercept. Okay, so that's important because many times they're going to want you to graph something based on the formula without putting it in your graphing calculator. So how do you do that? Well, the y-intercept is key, and they just hand it to you on a simple platter. No math required. You just can take that C, and that's your y-intercept. The factors, say you have x minus 5, for example, and x plus 2. These factors give you roots, and those roots tell you, so let's just make things up. What if I say, okay, my roots are 5 and -2? That means, okay, so Alicia made it. So let me get Alicia in. So that means that you have 5 here is a root, 2 is here, and let me make my y-intercept -7. And here is -7. So just based on this form, what I can do is I can graph an approximation, a pretty good approximation of what this looks like. Now, if I use my vertex, I can make it even better. But from standard form, you get three things. Okay, you can get your roots. So here's a root, here's a root, here's the y-intercept. Now, is that exactly right? Maybe not, because I haven't considered what my vertex is going to be. The vertex is either the lowest point or the highest point. That I need to get a good picture. Okay, but that's where we're going with this. So example one, they say, okay, find the vertex and sketch this graph. Okay, so it's all about finding the vertex and sketching graphs. So that was the piece I didn't do. I didn't find the vertex. So right now, looking at that, what I can see is that I easily have a y-intercept at 100. Okay, so I could factor that, but I'm going to skip ahead and find the vertex because that's what they asked me to do. Remember, the vertex is negative b over 2a. Then once you get that x value, you're going to plug that back in your function, which is here, and get the y value that goes with it. So if your a is 1 and your b is negative 10 and your c, I'm just going to throw this in here even though we don't use it, is 100, this is what I'm getting. My vertex is negative of negative 10 over 2a, negative of negative is positive, 2 goes into 10 5 times. So far, I know that the x value is 5. That's the x value of my vertex. Next thing, evaluate this function at 5. So you're basically going to take that function and wherever you have an x, every single time, you're going to plug in a positive 5. So this is 5 squared minus 10 times 5 plus 100. So that's going to be 25 minus 50. So that's minus 25 plus 100. That makes it 75. So this equals 75. So what do I know? I know my vertex is 5 comma 75. So at this point, I know this. My y-intercept is at 100. So I'm going to be way up here. Let's say that that's 100. Then I have a vertex at 5 comma 75. So let's say it's my x value will be 5. I'll make that go by ones, and I'll make my y-axis kind of go by 25s. So this is going by 25. So that's 25, 50, 75, 100. And this is going to be 5. So I have 2 points. So this is a point right here where my vertex crosses at x equals, here we go, at x equals, at y equals 100, so x equals 0, and then do your vertex. My vertex is at 575, which is right here. So what do I know? I know one thing right away. Anybody know what I know? I'm going to probably go to DJ. What do you know? What would have happened had I tried to factor that original form? So what do you think, DJ? What would have happened?
So I would, so
Go
you're
ahead.
saying you would have to use, oh, because it's not, hold on. So is that the same one? Did you just make up x plus minus 5 and x plus 2, right? That was a given example, right? You just made that up?
I just made that up above.
Oh, yeah. So
So
it means that the solutions are imaginary, right? Because it's not crossing the
Right.
x-axis.
Right. So what you would have, you could not factor it. You would
Yeah, you'd have to
to
use a
use
quadratic formula. Yeah.
So and that's probably why in this example, they didn't say, go ahead and find the roots as well. There are no real roots. That means you're going to have an I in your roots. And I don't believe we talk about that I in this course.
Yeah.
But
So a
that's
negative
why they
discriminant.
said, just, find those 2 points. So here, without even knowing that you have imaginary roots, imaginary means that your function does not cross the x-axis. So at no point will it cross the x-axis. So therefore, you cannot factor. You can use quadratic formula, which we talk about in the next section, but you'll get an answer for both of your roots that have the letter I in it, which is an imaginary number. So that's what's happening here. But just doing what we did, we have a pretty good idea of what the picture of this is. So if this is some kind of profit function or cost function, say, I can tell you that I'm going to minimize my cost if I operate at 5,75. That minimizes my cost. And that would be the application that you would do. If you want to find out what's the least amount of cost you can have, this is my cost function. That's what it's going to be. And as you move away from the X value of 5, you're going to increase your costs. So you can't get any lower than that. The fact that the arms of the parabola are going up, that happens because your X squared has a positive coefficient. So I think we looked at that before. That's why that has that. Okay, so a couple of terminology points from the textbook. They refer to standard form as ABC form, and that's because of the fact that we can identify ABCs, and we use that a lot when doing quadratic formula or when trying to do your vertex from the standard form. As opposed to the vertex form, which we're going to get to right now, which is called the AHK form. So what is this H and K stuff? Well, the H is so I think I'll put it right here. The H is the X value of your vertex. The K is the Y value. Okay, so when you're in vertex form, you see that right away. So what does this mysterious vertex form look like? So this is what it is. It looks like something like this. Okay, so notice you have squared, but you have parentheses around it, which is a different look than what we're used to with that ABC form. So the generic form of a vertex form is Y equals A times X minus H squared plus K. Okay, that is your vertex form. And then looking at that, your vertex is H comma K. So things to be aware of. When you're in this form, the operation connecting your H and your X is a negative. And the operation connecting your K with the squared term is a positive. So that's the generic form. Now, if your H is itself a negative, it'll appear as X plus H, which is what happens in this example. But know that this is the generic form. So here is my generic form of vertex form. Okay, so how do I get to that form? So they are showing it to you here. So let me see what they're saying. They're saying, okay, they're going to switch back. They're going to say, okay, we walk into this problem and it's written in this form. This I recognize as vertex form, but I'm not totally comfortable with it. So I want to switch that back to standard form. How do I do that? This is what you do. You're given this. Instead of having it written as X plus 7 squared, write it out. These are your factors. Write them twice because it's squared. So you've got the same thing twice. Then your next thing is to multiply the factors. This is also called foiling it. So you do your first, your outer, your inner, your last, and then you combine like terms. So let me do that for you here because they skipped right to the answer. So you have your 3 that just comes along for the ride. I have X plus 7 times X plus 7. So I'm going to do my first ones first. So my first is X times X. Okay, and that gives me X squared. So let's we'll play around with some color here. So we'll say the first is the green. It gives me this, and I did this times that. Then I want my outer. My outer are going to be, this is an outer, this is an outer. It's the outside. So outer is going to be x times 7, or you tend to write it 7x. Then the next one you're going to do is your inner. Inner is 7 and x, and the signs come along with it. Everything's positive here, so I haven't really been stressing that. That's another 7x. Then your last, we'll do in brown, your last is going to be your 7 times your 7. So that's 49. So what do you get from all of that? So you get, and I'll change colors, x squared plus 7x plus another 7x plus the 49. Combine like terms, and you are where they are. Okay, so they would write out the factors. So now that what they're trying to do is they did this, that piece, right? So they got this. So this is my red. That's their red. It matches my red. Now, don't forget, after you do this foiling, you still have this -9 kind of hanging out. So now you're going to combine like terms, but really super carefully. This piece is often overlooked. You've got to distribute this. This 3 belongs to the x, the 14, and the 49. So you've got to make that happen first. PEMDAS says multiplication takes precedence over subtraction. When I multiply, so I do this distributing right here, I get this. Now I can combine like terms with that -9. And now finally, my last thing is to group the constant terms, add like terms, the constants are like terms, and you get that. Okay, so basically all you did was FOIL the square term by multiplying by itself, and then you distributed the 3, and then you combine like terms. So you have not now gone from the AHK form to the ABC form. So this is your A is 1. This is your B, includes the plus. This is your C, includes the plus. So you've moved to that form by doing an algebraic manipulation. Okay, how does that seem? You may need to go back and look at that, but know that there's no assumption you're going to look at that and say, I know what the answer is. You've got to work through it. So just be systematic. Don't try to rush the process. Do the x plus 7 squared first and write it out for yourself. Don't try to do things in your head. That usually is the kiss of death, because you can't check your head, for one. And so when you go back and look at your work, you're not exactly sure where it came from unless you spell it out. So spell it out. It's a good modeling for the kids as well. I find a lot of the teenage boys tend to do things in their head, and that's fine in the lower maths, but it really is difficult at the end. Thank you, DJ. Yeah, I don't know what it is, but it's interesting. So the more you can get them to write it out, because it is great to do mental math, but there's just a time and a place. When you're doing this, this is not a mental math exercise. When you add 9, or when you subtract, 147 minus 9, go for the mental math. But when you're trying to FOIL and do all that stuff, write out your steps so that you can see what you did. You're much more likely to catch your own mistake if you do. Okay, so that's just going algebraically from standard form, which is the form you're most familiar with, to from vertex form back to standard form. Okay, so that's what they did there in example 3. So then they say, okay, let's go ahead and make sure that you can do this. So why don't you go ahead and try to do it? And I will do it here, but I won't say anything. And look up if you need support. If not, wait and surprise yourself at the end. So how are we doing? Good. So Alicia, I haven't talked to you yet tonight. How is this looking for you?
I'm just jumping in there, working it out.
We are proud of
It's
you.
pretty much what I got, pretty much.
Okay, good. So I wanted to take a second just to talk a little bit about PEMDAS. So they always say make sure to follow PEMDAS, but once they explain it once, they never really go into it again. So PEMDAS tells you the P is parentheses. You do that first. So if you have a parentheses situation like we had here when we expanded, I dealt with the parentheses first by doing the foiling method. Okay, so I foiled it, foiling, and foiling is just distributing in I guess somewhat of a fancy way. So it's first, multiply the first of each parentheses, do the outer, do the inner, and do the last. With PEMDAS, where it gets confusing is this. The P and the E, no problem. Do parentheses first. If you have an exponent, deal with that also. Okay? M and D, it does not mean do multiplication and then do division. Think of multiplication and division like the king and the queen in a egalitarian system, meaning they're both the same level of influence. If the multiplication comes first, you do that first. If the division comes first, you do that first. You don't do the multiplication ahead of the division. They are equal partners. Okay, and then think of the A and the S, the addition and subtraction, as the siblings. Okay, you love all of the children equally. Whoever comes through the door, you greet first. If addition comes through first, you say, addition, how are you doing? Nice to see you. You don't say, wait a second, I have to get subtraction first. Okay, whoever comes through the door first in a problem, do that first. If subtraction is first, welcome them, do that operation, and then do the addition that comes next. Okay, so they're not really in order that way. Know that multiplication and division are equal partners, as is addition and subtraction. That is really important. It doesn't get stressed enough. And people on Facebook always post the problems. What's the answer? And it's because of PEMDAS not being followed that you get, several different answers. So anyway, I just want to mention that because PEMDAS is critically important, but you have to apply it the correct way. Okay, so now we're going to do some how do we get from one form to the other. So the first strategy we're going to talk about is the easier one. How do you convert from standard form to vertex form? Because we haven't gone that way yet. We've only gone from vertex form back to standard form. So this is how you do it. It says first you want to recognize what a perfect square looks like. Okay, so a perfect square is something like this, where both factors are completely identical. Okay, so that's going to come up in completing the square, which is what we're going to do. So this is what we're going to do. They have it written down here, but I'm going to do it and talk about it as I do it. And hopefully that'll help because you'll have two versions of it, my step-by-step and what they have here in summary form. Okay, so you get a problem and your problem is in standard form. How do you convert it to vertex form? This is what you do. You start rewriting. You say f of x equals, and this is what I do. I have x squared plus 14x. Okay, all the terms that have an x attached, keep them grouped. Give yourself a big old gap and then put plus 9 here. Okay, so I've given myself a gap. What goes in that gap? Well, I'm going to underline this term, 14. You're going to divide that 14 by 2 and then square the result. So 14 divided by 2 is 7. When you square it, you get 49, and you get a positive 49. So you're going to add 49 right here. Well, how can I do that without changing the problem? Well, you're going to subtract 49 right next to it. So you have not changed the problem. Then you're going to start to recognize this right here as a perfect square. What multiplies to 7 to 49 and adds to 14? 7 times 7. So when you divide by 2, you kind of saw it. It was a 7. This is going to be x plus 7 squared. Okay, because when I divided 14 by 2, I got 7. That's your doorway to what your next step is going to be. So now I have a situation that looks like I'm getting close to the vertex form. Now keep going. Don't forget that you have a negative 49 and a positive 9 that are now like terms. Negative 49 plus 9 gives you a negative 40. So there's your new form. That's your vertex form right there. So key points. This middle term right here is key. That middle term, you're always going to divide by 2. That's going to give you this number. Okay, 14 divided by 2 is 7. That gives you the x plus 7. Then once you have done that division, then you're going to square the result. That gave you the 49. You cannot just willy-nilly add 49 unless you also subtract 49. So you have not changed the problem. You're only changing the format. Okay, so what does vertex form look like? So vertex form, let me just write this over here because we want to figure out what the vertex is. Vertex form is sum A, which we'll get to later on, x minus h squared plus k. Okay, so if this is my vertex form and I have x plus 7, then in a prior life, it could have been x minus a negative 7. And then this could have been minus a minus 40, because I have to read this form. Oh, sorry, it's minus 40. Hold on, let me just regroup on that one. We're going to leave that one be for right now. So let's just leave that as minus 40. Okay, so what do I know? I know that in terms of this, my h has to be a negative 7. Okay, and since I want this to be a positive, it's going to be the same thing. It must be that my 40 is a negative, that my k is a negative. Because if to get the 40, I must have said plus a minus, and that would have given me a negative. So here is my vertex. It's going to be negative 7, comma, negative 40. And if you did the negative b over 2a and the function evaluated at negative b over 2a, would we get the same thing? So negative b would have been a negative 14 over 2, bingo, that's the negative 7. And if I plug a negative 7 into this, I would get a 49 positive. I would get a negative here, so let me not put a positive there. So 7 times 4 is 28. Put down the 8, carry the 2. 7 times 1 is 7. 8, 9, plus 9. When I added those together, I'm going to get a negative 40. So that checks also. So I can verify it when I'm first starting out, and I'm a little bit shaky if I'm doing this correct. Don't forget, you've got this in your back pocket. That's your vertex from the standard form. Okay, so you can get it that way. Okay, so I'm going to do another one all the way through again, and I'm going to have you do the third one. Okay, so let me do this other one all the way through again without any extra writing that they've done. So I look at this problem and I say, okay, that is clearly in standard form. That's in my ABC form. And I need to get it into AHK form. So I'm going to start writing it again. It's still f of x, that doesn't change. I remember I'm going to group all of my x terms. I'm going to give myself a big old gap, and I'm going to bring that -2 over here. Then what should I do? Come over here to the +12. Divide that by 2. And I'm going to write 6 up here because I'm going to use that in a second. I divided it by 2, I got 6. Then I squared that. Everything's positive, so that's +36. In order to balance things out and not create a new problem, I had to subtract the 36. So now I have everything all lined up. Don't do that math. +36 minus 36 is 0. That's going to get you down the wrong path. Instead, focus your attention right here. Remember the 6. Factor this. That's going to be x plus 6, not b, but +6 squared. Then add the -36 and the -2, and that's -38. There you are in factored form. What is your vertex? So now I have AHK form, but remember my H part of it, they're expecting a -6 or a negative number. So if I wrote a positive here, that must mean that my H equals -6. That's how it got to be positive. Same thing here. -38 had to be a positive, so I must have been a positive of a negative, and therefore my K is also -38. So my vertex, which is what the whole purpose of doing this is all about, is going to be -6, -38. And again, I always have the back door of checking this. Go back up to your standard form, do your -b over 2a. That's going to be -12 over 2 times 1, which is 2. Bingo, that is -6. So that's good. Then take your function and evaluate it at -6, because you want to get your K term to make sure it's correct. You're aiming to get a -38. So that's going to be +36 minus 72 minus 2. So that's a -36 minus 2. Bingo. That's a -38. We got them both correct. Okay, so when you do it, I would encourage you to take this approach where you give yourself a big empty space here. And so these were all the original numbers. The yellow are what you got by taking the B, which is the +12, and divided it by 2. And then you squared it. And that's where you got a +36. And then I had to balance it out, so I gave a -36 right next to it. But then don't combine those two opposite numbers. Put them in different places, use them for different reasons, and you'll get your vertex form. So why don't I put you, does anybody have any questions on what I just did? Does that kind of make sense? You've seen it now twice. It's going to take a little bit to have it be something that you're comfortable with. So allow yourself that, that lovely struggle where you have that breakthrough coming. It's coming. That slight headache, it's not going to kill you. It's going to be fine. But you have to kind of be flexible with your math here. So I think you probably benefit from chatting with each other. So can I stop sharing right now, and I'll put you into groups so that you can talk about the next one? Is that okay? Do you have what you need to have down? Alicia, did I give you enough time to write this down? Okay, so let me stop sharing for a second. And then what I'll do is I will do the breakout rooms. And so I would say, let's see if we can do 2 breakout rooms. And I'm just going to say create. So just when you see the breakout room come up, then join it. Okay, so I'm going to open all the rooms and figure we'll take about 5 or 6 minutes and see where you are. And then we'll talk about it when I bring you back. So DJ, you want to hop in so that Angela's not by herself. Okay, good.
You better not be bad.
Okay, so it's just going to switch over. I'm going to just get back to my screen. Okay, so let me close that. Okay, so I think everyone got 8 comma negative 49 for their vertex. But let's go over, I'm going to show you my steps, and then I'm going to analyze how I know what the signs of the vertex values are. So first off, I'm going to play around with color here a little bit. I have f of x equals, so now I have x squared minus 16x. I'm going to keep those close. I'm going to take this negative 16 and divide by 2, and I get negative 8. I'm just going to throw that over here because it's going to come up in just a second. Okay, once I have negative 8 and I square it, that's always going to be a positive. So that's going to be plus 64. But in order to keep my algebra straight, I also have to say minus 64. And then I have to continue with the original equation. Okay, so then here's my new team. Okay, that's my new team. I'm going to factor that. The fact that I thought through this already brings me right to this factor, and I square it. Okay, so then I now need to combine these. And if I have a negative 64 and a positive 15, that's going to give me a negative 49. Okay, so far I have f of x equals. Okay, so now I have it clearly in vertex form. So what is the generic vertex form? Okay, so that is, and I'll change color again. So that is f of x equals a times x minus h squared plus k. Okay, we haven't addressed a yet, but a in this case must be 1 because there's not a number out there. So that's okay. That's coming in a second. So I just thought I'd point that out. Okay, I want to figure out what h is. So I look and I say, okay, what kinds of things match? So my x looks nice. Oh, this looks nice. So therefore, my h must be an 8 because everything else is matching up. So far, I know that my x has to be the 8, not a negative 8, because a negative is what I have there that matches up already. So that matched that. That matches that. So then this is what I want to use. Okay, so then go to your k. Oh, the k doesn't match. So look, this does not match that. So this must have been a plus of a minus, and the minus overrules it. So you never write 2 operations together. So that's what must have been happening, a plus of a minus. And then I wrote it as a minus because the minus always takes precedence over the plus in this situation. So since my k matches this, so let's see what it's going to match. My plus matches this plus, so therefore my k must include the negative. So that is going to be positive 8, comma, negative 49. Does that help in terms of understanding the signs? So use that vertex form and analyze it directly like I just did. If that had said plus 49, I would have had a positive 49 for my y value of my vertex. So remember, the vertex in this situation is the lowest point of the parabola. Because sometimes we do all the math and we lose track of what we've just figured out. So what do we know about this? We know that this is 15, is the y-intercept. And then I have an 8, which is the x. So let's just say, for argument's sake, that that's my 8. And here's my negative 49. So here's my vertex. So this is what I know about my parabola. Because my vertex is all the way down here at 8, negative 49. And I know because my A up here is positive, it must be reaching up. So that's what my parabola looks like. And the vertex combined with the y-intercept gives me a pretty good sketch. Without grabbing a calculator, without doing a t-table, without doing anything else, I have a good sense. I also know that my roots will be real and not imaginary because they have to cross the x-axis about here and here. So I'm thinking they're both going to be positive, but I could have one be negative depending on how I draw it. But I do know that I will have no imaginary roots. It'll have to cross. Okay, so just having the vertex form gives you all of that information. So that's that one. Are we feeling kind of comfortable about that? Because there's more to come. So that was the easy one because as I pointed out when I solved it, A is 1. So that means the leading coefficient, the A in the standard form, was 1. What if it's not? It's not the end of the world when it's not. Things will work out. It's just a little bit more challenging. So this is going to be a little bit harder, but we're going to follow the steps as closely as we can. And then I'll show you where to be careful. So first off, here's an example where you have a situation where standard form reveals that the A is a -2 and not a 1. So I have to have a different approach. So look what they're doing. They're just saying, okay, that -2 is a problem. I need to still pair my square term with my linear term. So this is what I'm going to do. I'm going to factor out the -2. So here it's gone. And I'm left with a t² minus 6t. I still keep that -23 away. I don't involve that in what I'm doing. Okay, then go through the same steps you did before to a point. You're going to say, okay, what's inside? Well, what's inside there, let me change my color here, is a -6, right? This is a -6. Divide that in half. And I would still write that someplace here so that, oops, not in highlighted though. Write it someplace so that you have easy access to what that was. When I divided it by 2, I got a -3. Then square that, you get a +9. Okay, so we're okay there. Now, you're not going to subtract 9 because that -2 out here really means that you added a -18. So you have to do the opposite and add a +18 and then continue your function. Okay, so that's the difference. You factor the 2 out, the -2 in this case, but before you balance out your equation, you've got to consider what you've actually added. In the parentheses, you just added a +9, but in reality, you added a -18. And that's why you're going to add back in a +18. People tend not to try to combine the +9 and the +18. That's the good news with this form, because they don't look so much alike. But you've got to recognize what you're actually doing versus what it looks like you're doing. Then you get to that last step, and you're back to using this -3, just like you would have. Add the +18, the -23, you get a -5, and we now have our form. Again, to make life easy, I'm going to write the standard form right here. They changed our variable to a t, which is totally fine. A lot of times you'll have t in math because t tends to stand for time. So this is going to be t minus x squared plus k. So let's match. Because this operation matches that operation, then the 3 must be my x. That's how I got the 3. Then this says a minus 5, but this says a plus k. So therefore, my value for my y is not 5, but it's minus 5 for that reason. I had to change the sign. And now we're back to vertex form, and you've also identified your vertex. So let me do one for you. Oh, and the other thing is your A is no longer 1, your A is now -2, which becomes a factor in our next example, or 2 examples from now, when they talk about using -b over 2a to get the vertex form, and then having to solve for the A. So that's what's coming, but let's not get ahead of ourselves. So let's look at this. When I observe this, what I'm seeing is that this is my A. My A does not equal 1. So I now know I have to factor that A value, which is 4, out of both the quadratic term, which is the x squared coefficient, and the linear coefficient. So I'm going to start out by doing that. So I'm going to say, take my 4 out. That gives me x squared plus 8x. Okay, key thing here. We are not doing greatest common factor factoring. If we were, we would have taken out a 4x. So we're not doing that. You're just dealing with the number, the A value. You're factoring out that so that it returns to being a 1 as a coefficient. Okay, so I'm at this point now, and I say, okay, I have a positive 8. Divide that in half. Oh, that's going to be a positive 4. I'm going to throw that over here. And square that. So if I square a 4, I get a positive 16. Close your parens. You can write your negative 15 over here if you like. And now you're going to say, well, what did I actually add? I added not 16, but 4 times 16, which is 64. So I had best subtract 64 so that the algebra police are happy with my work. I can't change the equation. I have to keep things balanced. Just like in Chem Lab, you keep things balanced. Got to keep it balanced. I have to subtract 64 because it looks like I added 16, but I actually added 64. So do the opposite, subtract 64. Okay, so now I have that 4 hanging out over here on my left shoulder. That's going to be instrumental in getting the squared term. And then both of these values are negative. So a 4 and a 5 is a 9, and a 6 and a 1 is a 7. And they're both negative, so that's negative. Okay, so that's my factored form. Okay, what does that give me in terms of my vertex? Well, let's think about that. My standard form of vertex form is going to be A times x minus h squared plus k. So what are you seeing? This can't be a 4. It must be a -4, comma. This can't be the k. It must be a -79. And that's my vertex. And what was your A? Your A was 4. Okay, so let's try to do, should we just do this one? I'll just verbally kind of do it, or you can, why don't we do it so that I won't say anything, look up, see how you're going, and if you need support, check my work. If not, just keep doing what you're doing, and then we'll talk about it when we're all done. Okay, so how is this looking? Okay. Okay, DJ, did you do what where A does not equal 1 with your class? I don't know if you can hear me. We'll see if we get it back. Okay, so this is what I'm getting. I'm getting 2 and 10. Now, let me tell you what I find for my kids whenever I do the completing the square when A does not equal 1. A common problem is this. They are really good about saying, oh, I didn't really add 4. I added 12. Then they add 12 again. Instead of saying, oh, I added 12. What's the opposite of that? I have to subtract 12. Because when your brain does that one step of math, you kind of think, well, that must be what I have to do. But it's not, because you always want to do the opposite so that you keep things balanced. And then I think writing your vertex form, your standard form of it, right underneath your answer will be key in analyzing your solution in terms of what your vertex I'm better. In terms of what your vertex is. I'm gonna grab some water. Be right back. Much better. Did anybody else grab something as you were going through it and you thought, oh yeah, I have to really watch for that step? So are you comfortable just factoring out from the quadratic term and the linear term? So just do that, give yourself a lot of space because you don't want to forget that you have to complete the equation. You've got a plus 22 in there that you've got to deal with. So I would always just write that down until you figure out the rest of it. And then I do like kind of thinking this through once and writing it off someplace and then coming back and plugging it right in. You can go to the next step and start writing it, but I just kind of do this because you never want to have to think through things twice. You go through once, you then squared it. And so before you square it, write it down so that you're already there at the next step. Okay, so that's that one. Okay, so now you know how to complete the square to get to vertex form, whether you have an A of 1 or not 1. You also know how to go from vertex form to standard form by foiling and then combining like terms. So now the next piece they want us to do is to say, okay, we're going to look and we're going to say, I knew from the previous lesson that we can get the vertex without having vertex form. So what they're explaining here in great detail is that go ahead and get these values and then just plug it into the form. Because from the standard form, which is here, okay, so here's your standard form. From this, you get your A. So I know my A. You get your other values of B's and C's, and you know that you can get your H this way and your K this way. So there is another way to either check your work or just to show that you can get it this way. So that's what they're doing here. So they're saying, okay, let's use this method instead. Take your standard form, identify A, identify B, remember it comes along with its sign, identify C. Find the X value of the vertex, AKA the H, right? By saying negative B over 2A. So if you had a negative 12 already, a negative 12 is a positive 12. Just be careful about that. And then 2 times 3 is 6. So that's going to be 2. That's the H of my vertex. So then you're going to evaluate the original function, that's your original standard function, at 2. All that means is wherever you had an x, you're going to pop in a 2. And when you do that carefully, you'll get a -7. That's going to be your k. So now you can write it because you know that your vertex form is a times x minus h squared plus k. So the negatives are matching up because this is a 2, so I can just put the 2 right here. And then this is a -7, therefore I'm going to write -7 because it's the opposite of the plus. So now I have it all written in, and I'm back to vertex form without completing the square. Okay, and that, if nothing else, it's another quick way to check your work, because you can just plug these things in and figure out, did what you write down, did that make sense? And then what does this look like? Does that piece make sense? So now I have the C is 5. So what does this function look like? This is 5. My vertex is 2 for the x value, and then -7. So it's probably someplace down here, say. So I'm going to come here. I'm going to go down here. So I know that my vertex gives me this nice shape. And I know that my roots are real roots. It's definitely going to go through the origin. And because my A was 3, I know it's going to be upward facing, or concave up. So then here comes the mystery parabola. So now you're going to pull everything you know together and think about the A. So they give you some points. So they say, find the equation of the parabola in this figure. And this is more likely, like I said, I think I wrote to somebody, you know, life is kind of a word problem. They're not going to give you a whole lot of details. You're going to have a scenario, and then you have to figure out, okay, given that scenario, how do I attack this, given the information I have? And what techniques would I use? So they want the equation of the parabola, and they want it to write it in vertex form. So this is the things they want, and they want it in standard form. You've got to give them both. So they want both forms, AHK form and ABC form. So the question is, what would you get first? And I would say it's probably because they hand you the vertex. Since they hand you the vertex, you've got to get vertex form first. Okay, so I'm going to go through that. So what do I know? I know that vertex form is y equals a times x minus h squared plus k. Okay, so here it's critical. You cannot leave out that a. You've got to have that. Okay, so I know the vertex is 2, 1. So let's see what that does for me. So if it's a +2, then this is going to be x minus 2 squared plus 1. Okay, so that's interesting. So let me do that. So I'm going to try to simplify this. I have an A out front, but I can definitely FOIL this and see where I get. So that ends up being x squared minus 2x minus 2x plus 4. And then all of this is times a, and then a plus 1. Okay, so what do I do with that? So let's keep going. And then don't forget, this is a y equals. So y equals a, I'm going to combine like terms, x squared minus 4x plus 4 plus 1. Okay, resist the desire to combine that 4 and that 5. You cannot do it. I need more information because right now I have 3 unknowns. I have an A, an X, and a Y. So I can't really do a whole lot, but look what they gave us. They gave us the y-intercept. That is a point. That's an X and a Y. Plug it in. see what we're going to get. Okay, so if I plug it in, I'm going to find that here's my 3 equals this mystery A, which is my big problem child. Oh, my X is a 0. That is wonderful. 0 minus 0 plus 4 plus 1. So what do I have now? I have 3 equals A times 4. So this is 4A plus 1. Okay, that's interesting. So I want to get A by itself. Subtract 1, subtract 1. Now I have 2 equals 4A. Divide by 4, divide by 4. And A must be 1/2. So now I can write my vertex form. So here comes the vertex form, because the only piece I didn't know was the A. So what do I have now? I can go back up to this very first step when I just wrote it out and I was all fine. Vertex form is going to be y equals 1/2 x minus 2 squared plus 1. Okay, so then remember the very first lesson was in the section going from vertex form to standard form. All you have to do is FOIL and distribute, and then you'll get the standard form back. So now we're going to go to standard form. So we're going to take, like that, standard form. I'm going to take my vertex form and I'm going to follow PEMDAS. That means the first thing I'm going to do is to square inside here. So I have x squared minus 2x minus 2x plus 4 and then plus 1. So I'm going to still do my parentheses, x squared minus 4x plus 4 plus 1. So now I'm going to distribute that 1/2. So that's going to be 1/2 x squared minus 1/2 times a negative 4 is a negative 2x plus 1/2 times 4 is a 2. Okay, I don't need the parens anymore because what I was doing is I was distributing and then I'm just going to add a plus 1. So here it comes. Here comes standard form. 1/2 x squared minus 2x plus 3. So my A is 1/2, my B is negative 2, and my C is 3. Just curiously, because I know my vertex is 2, 1, if I did negative B over 2A, am I going to get the 2 at least? So negative B would be negative negative 2, so negative of negative 2 over 2 times 1/2 is 1. That equals positive 2. So I'm pretty sure that I'm going to get that correct because my X is correct. So if I just plug my Y in, I'm pretty sure I'm going to get that correct as well. But the fact that the X is correct gives me confidence that I'm doing this correctly. Okay, so that's probably the toughest one to do, to start to think, where do I start? So could I have started the other way? You would have had a lot more thinking to do because you would have had to figure out if your vertex X value is 2, what's negative B over 2A? And you'd be trying to solve for 2 unknowns. So you couldn't start that way. You have to start in vertex form. If they gave you the roots instead, then you'd have to start in standard form. But if they give you the vertex, you have to start this way. So the vertex makes you start here. So I'm going to say, if given the roots and the y-intercept, start with standard form. But you don't have enough information to start with standard form. So you can do this when you're comfortable, A, creating vertex form, and B, moving between the two forms. This is like your litmus test. If you can do this comfortably, then you're there. You've arrived. You can do, the vertex form. So, and you have to kind of be easy on yourself because it's not going to happen overnight. You just have to kind of think about it. Okay, so there's one more page that all really has, and then there's more practice. And what I'll do is, since I don't want to go beyond your 7:30, I will give you my answers for the practice so that when you practice, you can see if you have the right ones. Okay, so then the rest of the notes involve this. They summarize for you pretty nicely. Then they do this matching thing. So what you have to recognize is if you have negatives. So if you have a negative here for your A and here for your A, the negative means that you have flipped over the X axis. It's called a vertical reflection. So that means that C and D have got to be flipped over. Okay, what else do we know? So other things they want you to pick up on is this. If this number right here, ignore the negative. If this number is less than 1, then you have a vertical compression. And that means that you push your graph down. When you push your graph down, it kind of makes it look a little fatter, I guess I would want to say. So this is just directly, D is just directly, well, hang on a second, because these are switched. Okay, if you're vertically compressing, it's going to be what D looks like. Imagine taking your hand underneath it and pushing it up. When you do that, these arms go this way. So when you have a vertical compression, the arms go out this way. They go wider. As opposed to C, this is a 1. So you have no compression, and no stretch. So that's just your basic curve flipped over. So those are the bottom ones. The top ones, the A and the B, they're also switched. So this is B and this is A. Why? Well, this 2 in front is a vertical stretch. So if A is greater than 1, you have a vertical stretch. If A is less than 1, you have a vertical compression. When you have a stretch, think about grabbing the arms of the parabola and stretching it up. It makes it tall and skinny. Vertical stretch results in tall and skinny. And that's why A is your vertical stretch example. A vertical compression makes it short and fat, and that's why it is D. For both B and C, there's no change. It's just upward facing for B, downward facing for C. The A, which measures stretches and compressions, is just 1. So it's neither a stretch nor a compression. So those are kind of new things. I think I asked you those on the problem set too. So see if that can make sense to you. The negative sign does not address compressions or stretches. Negative just means flip over the x-axis. Okay, negative only means flip over the x-axis. Okay, you don't use that to talk about compressions. A vertical compression and a vertical stretch has to be positive numbers. If it's less than 1, it's a compression. It pushes it, the graph makes it short and squat. If it's greater than 1, it's a stretch, makes it tall and slender. Okay, so they want to kind of go over that a little bit, and then let me look at the more practice. So copy my answers. So when you do this, you can check to see what you have. So I'll write these above. So the first 1 and 2, they want you to get the vertex form, and for both of these, A equals 1. A equals 1. So I got this, x minus 4 squared minus 5, and this is x minus 6 squared minus 12. And then here for the next 2, you're going to say that A does not equal 1. A does not equal 1. So these are both going to be stretches, by the way. So this is going to be a stretch. And this is going to be a flip and stretch based on what my A's are. And my vertex form here is going to be this. So then the next 2, they're going to have you go from vertex form to standard form. So just a note, this is a flip and a stretch because the A is 3 and you have a negative, and this is no change. The A equals 1. So A equals 3 here. Doesn't equal negative 3, A equals 3. So when I write this in standard form, what I got was y equals negative 3x squared minus 18x minus 20. And then the next one's going to be x squared plus 2x minus 3. Okay, so note to self, if you have a negative here, you have to get a negative here. If you don't, something is wrong. Okay, because that property of that quadratic being flipped over the x-axis didn't change. It's true whether you're in vertex form or standard form. And just likewise, your A's will always be the same because the A is very predominant. It's very much stands out there, whether you have vertex form or standard form. Okay, there's your A way out in front. It has to be the same for both. If it's not, that's a good place to go back and check because they're not going to change. It tells you something specific about that graph, and it's consistent despite the form that you're in. So see if you can get these factored form or standard forms, and if you can't, shoot me an email, and when I'm going out of town for Thanksgiving, when I get back, I'll go over it with you because this is important stuff, and it'll really impede your progress in the problem set if you're not comfortable with this. So these are the answers, and if you're getting something different, let me know and we'll work it out. Okay, so this was a big lesson because we covered a lot of material. Usually when you teach this, you don't do both forms where A is 1 and A is not 1 in the same lesson. You give them kind of time to practice and digest it. And you certainly don't throw in the fact that, oh, let's work backwards and let's do this other stuff. Okay, so there's a lot in one thing, but it's all good stuff and it's all kind of related. And it's just all kind of adding to your math sense and your math, fluidity going from one form to the other. So see if you can stick with it, and I'm happy to help you. If you have any worries about it, or you just are questioning whether you're doing the right steps, just reach out to me and I'll get back in touch with you and we'll go over it. Because next week is a video lesson. And I'll give you a preview of the video lesson. That's going to be all factoring. So you definitely want to have this down. And then if you know that factoring is a problem, once you see it, using quadratic formula is a problem, definitely before the following class, we should get together on Zoom, because it's a lot to cover and you just need to give your brain time to digest it. It's a lot of moving pieces, and this is a really challenging stuff in Algebra 2. And this is why when we get to pre-calculus, a lot of this we go back over, because you just need a couple of exposures to really understand it. And if you're not doing this in your everyday life, and most of you probably are not, then you have to kind of give yourself time to make those brain pathways again, so that it's a comfortable process for you. So anything for the good of the cause? So this was good. So I'll post this recording after our class is over. So that'll be up under today's date, because I know that Tristan had a conflict. So I want to make sure that she has access to this and see where you are. So the book is a help. Hopefully these notes are a help, and then see what you think. And just be patient with yourself, because you'll get it. Okay, well, I want to wish each of you a happy Thanksgiving. Have a great time. Hopefully you'll be seeing some family and friends, and that'll be good. Take care of yourself. Take a little rest.
All right, happy Thanksgiving.
And it's tough.
Thank you.
I do have one question. So
Yeah.
next week's the video, and then is the 5th when we do our presentations?
Yes. So for the
And-
presentations, what you should think about doing is you have like an article that you're going to kind of base it on. Do it as if you were going to do a presentation to your class. So
Have you been over your classes out yet?
a good thing is to have like slides, clearly slides. If you would give handouts, have that be part of your presentation. Like now at this point, we would take a break and we work on this. So have it be like that. Figure, 5 to 7 minutes or so, just to go over and show how you saw the way you can apply this to your class, how you would present the information. And I think it talks more about that in the syllabus, but that's what I'm looking for.
And then the final test is the following week, and that's it.
Then that's it.
Wow.
I know, no, it's hard to believe. So, in between those things, if we need to have an extra session, that's okay. Just, let me know, because as I said, this is a lot of stuff. I think the beginning stuff, I think people are comfortable with. It's this stuff at the end that's more challenging, especially the factoring. And, I factor by decomposition, and you may find I'll talk about it in the video, but you may find that you always want to do decomposition, and you don't want to have like easy factoring and hard factoring. So you're going to have one approach. And I do tons of decomposition. So I'm always teaching that and reteaching it to people. Either I teach or I tutor. And so I have a lot of good strategies with that I tried to share in the video. The other thing that's in the next week's lesson is using quadratic formula. So you can always use quadratic formula. When you use it and you don't have roots, when your parabola, say, is always above the x-axis, you're going to get imaginary numbers, which means you're going to have a negative under a radical. That's what that means. So a lot of times my kids will say, oh, there's no solution. Well, no, there's a solution, but you can't factor it. It's not factorable, but you can still get a solution. And sometimes if you have square roots also, perhaps it's not factorable, but quadratic formula allows you to get a solution. And that's all related to parabolas. So we did one part of it tonight. Tonight we focused on the vertex, which is either the max or the min of the function. And next class focuses on the roots, where it does or does not cross the x-axis. And you have access to a graphing calculator too, so you have a lot of ways of reinforcing that information, because those roots are where your y equals 0. That's what's happening. So your y value is 0. So, calculate, using a calculator for reinforcement is a very good idea because it does allow you to see it a different way. So anything else? Is that, Angela, did I answer your question okay about the presentation? Okay. Okay, and then just post whatever you're going to do, post it on that day. And then, because this way, I could look over it at my leisure too and give you a grade for it. But we could potentially share it with each other. If you know that someone, is going to do something similar to what you've just done, we can share that information then. Okie doke. All right, well, happy Turkey Day, almost here. And I will see you in 2 weeks, but I'm not, don't be shy about reaching out before that, because I'm happy to go over whatever you have here. It's easier to do this in little pieces than to try to like get a situation where you're snowballing and then you're thinking that you don't know anything, where you know a ton of stuff. It's just all in there right now. So anyway, so good job tonight. And I will see you pretty soon. Have a good Thanksgiving and reach out if I can be of help. All right, bye-bye.
See ya.
See ya.
Dr. Riley, I do just have one quick question for you. I was kind of jotting down ideas for number 2 on this one, on the practice problems.
Yes.
And I guess I got the right answer on like the x minus 6 squared, but I'm getting thrown off with how like it's supposed to be negative, but I ended up with -8.
Okay.
Or -8, I should say. I'm sorry.
That's okay. So this is number 2 on the very top.
Yes.
Okay, so when I tried to complete the square, I have x squared minus 12x plus 36 and then plus 28 minus 36.
Yes.
So are you getting x minus 6 squared minus 12?
I'm getting x minus 6 squared minus 8 because when I tried to do minus 36 plus 28, it gave me -8, not -12.
But if you put in your calculator, oh, wait a second. It is 8.
Okay, I was like, I don't know if I'm gonna switch this up to fix it.
Yeah, so that's your
Okay.
So this is 28 minus 36, which would be -8. Yes.
Okay. I just wanted to check and make sure I was doing it correctly.
No, you are good to go.
Okay,
So
thank you so
what'd you get for the
much.
first one? Now that I'm nervous about this, do you have
I got the first one.
x minus 5 minus 4 squared minus 5? Is that okay?
Yes, got that.
Okay, so that's good. So I'm so happy that I haven't turned off the recording. So the second answer is indeed x minus 6 squared minus 8. So you are the completing the square queen for the day.
Gosh.
So that's great.
All right.
I can do these things over and over again and just totally miss that.
Yeah. That's why I was like, am I missing something? Because I have no idea how to change this up to look at it the right way
Right.
to fix
In
it.
my mind, I went the other way,
Yeah.
but I kept the negative regardless because I just like the negative, I guess.
Apparently.
But yeah, I'm just looking. Other things look good to my naked eye. If you were to find
I stopped
something-
it too because I was like, if I'm not getting this right, I need to stop before I do
right
the
before
rest
you
of
get
these
10 more.
questions.
Right. No, you're good.
All right.
You're
Thank you
good.
so much. Happy Thanksgiving.
Yes, you too. Thank you for stopping me. That was fabulous.
Not a problem.
Very
Bye-bye.
good. Bye-bye.